Hi, my name is Harvey Raja. Now I work as a part of the Coherence team, and today I'm going to speak to you about some integration we've added in Coherence 12.1.2, and that's integrating with Maven. So we'll talk a little bit about the problem and why such integration is needed between Coherence and Maven, and lead on to why it's a broader problem and a solution can actually be applied to an Oracle home and all amiable artifacts within that Oracle home. And then we'll talk about the specific integration between Coherence and Maven, what we hope that makes anybody that uses the Maven build system and makes their life easier, and the integration with Coherence should be a bit more fluid. So Maven is a build system that's used by many organizations and many instances in the same organizations, and Coherence as a dependency fits into a Maven build system fairly naturally. Coherence is, if you look at the distribution, is a number of jars, and each jar has some unique naming to it as well as some version information. So whilst we don't provide the Maven metadata in the notation that Maven requires, a lot of it can be inferred and determined based on the information that's within a distribution. Whilst that is true, there are certain decisions that need to be made if Coherence is imported into a Maven build system. So let's take a look at how you would do that. So today you would download Coherence as a distribution. You would take out all the artifacts that you were interested in, and you would upload them into Enterprise Maven repository, so that each of your projects could depend on Coherence. Now, the problem with deploying it to an enterprise repository is prior to it getting to that enterprise repository, you must define the GAV parameters. So the group ID, the artifact ID, and the version. And this has an element of subjectiveness. So it's all down to the person that's uploading into that enterprise repository what group ID, artifact ID, and version they use. Now, the version generally is fairly consistent because it will align to an official version that we've released. But we've seen several instances where some people use Oracle Coherence, some use Tangslog Coherence, or some other notation. And as well as that, within the organization, all of the projects that depend on it would need to know that decision, what decision was made when they perform that, when they add the dependency into their project. So we hope that standardizing the GAV parameters for Coherence within the Maven notation and shipping with that Maven notation would solve this problem. We also lack an external repository. So unlike with some other components such as SLF-J or JUnit, which are available via public repositories and can be depended on without downloading from another distribution, unfortunately we lack that as a facility today. And like I mentioned before, it is a broader scope than Coherence. We do think this is applicable to other Fusion middleware components. So let's take a look at what a solution looks like. So unfortunately, we can't alleviate the problem of downloading a distribution. That is still required, and once you download the installer and install it on a local file system, the net result will be an Oracle home, and the Oracle home will contain a number of artifacts. Now, these artifacts are now eligible artifacts to be uploaded to an Enterprise Maven repository via a facility called the Maven Sync plugin. So the Maven Sync plugin understands an Oracle home structure, and it also understands some information in that Oracle home that allows it to determine each of the artifacts that are eligible, where they exist, where they live in that file system, and what GAV parameters should be used to upload those to an Enterprise Maven repository. And purely by executing the Maven Sync plugin against an Oracle home, all of those eligible artifacts will be uploaded to an Enterprise Maven repository using the standardized GAV parameters that each respective product group has defined up front. So this means that that element of subjectiveness that we mentioned previously goes away, and It's an upfront decision in terms of the GAV parameters that are made by the appropriate authority. And therefore, each of the applications can just depend on the correct dependencies. The other feature this brings is patches. So when applying patches and applying a patch to an Oracle home, the sync plugin can be re-executed, which will upload all of those eligible artifacts back to the Enterprise Maven repository. What this means from a project's point of view, they can depend on a version specific to a patch, or using the Maven ranges, they could depend on a major version of a product instead. So let's take a look at some of the integration specific to Coherence and Maven that we've added as part of 12.1.2. So as we mentioned before, through the sync plugin, Coherence is available as a dependency for applications and products to depend on in a Maven build system. Within Coherence 12.1.2, we've also added the notion of a grid archive. A grid archive is a jar file with a structure. It could be considered similar to a WAR, and the structure mandates that there's an optional lib directory within that grid archive which can contain many jar files. As well as that, there are some coherence configuration files and a descriptor. So to support the building of a grid archive and the creation of the grid archive, we thought it would be beneficial to provide both an archetype and a packaging plugin. And so the archetype is an ability to create a project and the project layout such that it's ready to be created as a GAR. And it's all homed into creating a grid archive. And as well as that, if you look at the generated POM file, you'll see that the packaging type is GAR. So we have a specific packaging plugin as well, which will take the structure of the POM and all the dependencies, and it will first of all go through the standard life cycles of building the actual GAR file itself, and it will end up resulting in a GAR file with all the dependencies put into a lib directory and all of the compiled classes into the GAR. And so the archetype itself will lay out some default files. So it will lay out a default coherence application XML, which is the descriptor for the GAR, and it will also lay out a default cache configuration and POF configuration file. In addition, the packaging plugin also supports the POF configuration generator, which is a new feature in Coherence 12.1.2. And now let's have a look at a demonstration on how this works. So here I have a shell window, and in my current directory I have the installer and a GAR directory. The GAR directory contains a pofobjects.jar, which is a number of Java source files that we'll use later on. So the first thing to do is to execute the installer. And the installer will create an Oracle home and will lay out all of the files into a local file system. So we'll just continue with this. And we'll just go through this wizard, just installing Coherence into a appropriate location. And now that's complete, we'll just finish out the installer. And if we have a look in our current directory, we can see we now have an Oracle home, cohome1. So the other thing I'll do, I will just set up an environment variable that I can then refer to in various command lines. Now if we go into our Oracle home, we can see that we have various directories. And the two ones that we're really interested in is the Coherence and Oracle_common. And so our first thing to do is, now that we've downloaded everything and laid it out on a local file system, is that we want to install the sync plugin. So this facility that we mentioned previously needs to be within a Maven repository so that we can execute it. So let's have a look at the command line that would do that. So I have that readily available here, and we can see it refers to the Oracle home, and under the Oracle common there is a plugins directory which has a Maven directory, and similar to the Maven binary repository, it has the package names as directories, and then we have the Maven sync plugin, the version, and the POM file, and there's also the associated jar file. And we'll actually use the install plugin to install that for us. So let's paste the command line and execute it. And so that's built it successfully, and if I have a look in my local M2 repository, we can see that there's now a Maven directory which contains the Maven sync plugin that we've just installed. What you should also notice is that under Oracle, under COM Oracle, there is no coherence directory in here. And we should see a coherence directory as the result of performing the sync plugin. So now that we've got the sync plugin installed, we're ready to perform the synchronization. So let's issue the command to perform that synchronization. Now I've just selected it here, and what we can see is that we execute it via Maven. We provide a command line option, which is the Oracle home. We then also specify test only to be false. So the sync plugin can operate in a test only mode, which is the default, and it will tell you the actions it's about to perform. Or you can turn it in a test only false mode, which will actually perform the synchronization, the push. So we'll just copy this command and issue it into the command line. So that goes off and executes and tells us exactly what it pushed in. And now if we look at our Maven repository, and if we look within Oracle, we now have a coherence here. So let's have a look under coherence. And under here, we have all the modules that make up coherence. Okay, so we can see that coherence core is here under 12.1.2, and that contains the jar file and the POM file. So that's the sync plugin and its ability to push into an enterprise Maven repository. The next part of functionality that it would be nice to see is the GAR. Okay, so let's just pop into this GAR directory. The first thing we want to do is let's execute the GAR archetype such that it creates a project for us. So again, in demo fashion, we have a pre-canned script that we can execute, which will execute the archetype. And this is very common usage of archetypes. So we specify archetype generate, we specify the group ID that for the archetype that we want to execute. It's the Maven GAR archetype and the version of that. And as well as that, we specify the group ID and the artifact ID of the project that we want generated. So we're going to have a group ID of ComAcme and an artifact ID of Adventures Cache. So let's go back to our shell and let's paste our script. And this will go off and execute. And it will create for us our Adventures Cache project. Okay, and you can see it asks us what version we want to specify, as we didn't specify it previously. And we'll just say yes to that. Now let's take a look at the POM file that it's generated. So first of all, it's generated a directory called Adventures Cache, which is now the root for our GAR project. And we can see there's a POM file in here. And let's take a look at the POM file. So the POM file itself has the group ID, artifact ID, and versions we mentioned previously. It now has a packaging type of GAR, and also it has a parent of Oracle Coherence GAR common, which contains some dependencies such as coherence. So let's kill this buffer and let's have a look at what else was laid out for us. So we have a source main Java, which is empty, and we also have a resources directory. The resources directory has a metainf directory, which has a cache config, a coherence application XML, and a POF configuration XML. So let's take a look at our generated or provided files. So we have resources, metainf, and let's have a look at our application XML file. And we can see that we have a cache configuration reference and a POF configuration reference. So these are just the default files that you'll find in the jar. And what we'll see is from the root project directory, we can do a Maven clean install, and this will build our project for us. And so it happens relatively quickly, and if we look at the contents of the generated file, and we can see it's the adventures cache GAR file, we can see that it contains nothing but the files that have been created for us, the cache configuration, the application XML, the POF config. We can also see that there's a GAR file and a jar file here. The reason for that is when the GAR is used within the context of an EA file. And what must happen is that, unfortunately, the way the web plugin works within Maven is that it only allows jar artifacts. So when it comes to doing a Maven deploy, we actually deploy both a GAR and a jar, so that when used under the context of an EA where there's a WAR, you can depend on the jar artifact to compile the WAR, but when it comes to packaging via the EA, you can depend on the GAR. Okay, so let's have a look at how this works with compiling some classes that are dependent on coherence. So let's pop into our source main Java directory, and we are just going to extract our POF objects jar into here. And this contains a number of classes that depend on the portable object annotations. So now if we pop up a number of directories and install via Maven, we should see that these files compile. And if we look at the contents of the GAR, we should see the class files are included. Something else that would be interesting to do would be to modify the POM file such that we have a dependency and ensure that that dependency enters the lib directory of the GAR. So here I have a snippet for a dependency, and the dependency is on JUnit, and I will add that directly into my POM file. So I now depend on JUnit version 4.8, and let's execute a clean install once again. And once we check the contents of the GAR, we now see that in the lib directory, which is pointed out here, we have a junit.jar. So the other thing that will be interesting to see is if we go back to our POM file, is to see the POF configuration being generated also. So the first thing we'll do is we'll just come back to the command line, and we will remove the existing POM files. So let's just remove from source main resources, metainf, POF config XML. And also let's take a look at the source main resources, metainf, and have a look at the application XML. And let's just remove this reference. Okay. So we have no POF configuration file, and if we do a clean install followed by checking the generated GAR, we should have no POF configuration file. And we don't. We only have the cache configuration and the application XML. So let's go back to our POM file and let's come to the plugin. And under the plugin, we can specify configurations. And here's one I prepared earlier. So let's just save a bit of time by copying and pasting this in. And let's just kill this buffer and let's go back to the shell and let's do a clean install. So this is now, as a part of the build process, it will generate the POF configuration for us. So the end result should be a GAR with all of those classes, the atom, the nucleus, the proton, the neutron, the electrons, that are actually annotated with a portable annotation. They should be present within the POF configuration. So first of all, this time let's actually go into the target directory because we want to interrogate the contents a bit more closely. We can see we have the GAR file here. And if we have a look at the contents of the GAR, we can see that it has a cache configuration, an application XML, and this time it also has the POF configuration file. Still has the JUnit dependencies and the classes. So let's take a look at the contents of the metainf directory. So within the metainf, we have the coherence application XML file, and we can see that the POF configuration file has now been put back in, and that's not present in the source directory. Let's kill this buffer, and let's have a look at the POF configuration file. And we can see that the POF configuration file now has all the classes that are within our source directory are put into our POF configuration file. So this means that as a part, if I just pop up a directory, as a part of the Maven build process, we can generate our POF configuration and have it embedded into our GAR. Well, thank you very much for listening to me on this Maven and coherence integration.